introduce to you our second speaker, Farzan. Trained as an electrical engineer 20-some years ago, Farzan likes to explain complex ideas and topics in its simplest possible forms. Today he'll be talking to us about electricity and some of the most basic principles of the electrical world. Farzan is speaking from the Competent Communication Manual. And his speech is entitled Electricity 101. It is 5 to 7 minutes. Please help me welcome Farzan.
Thank you, Jeanette, fellow Toastmasters and guests. Have you ever wondered what makes all of your wonderful electronic or electrical devices, your cell phones, your TVs, radios, washing machines, what makes all of this stuff run? Today, I'm going to be talking to you about how electricity actually works. The talk is titled Electricity 101, like a beginning college course, but it should really be like Electricity 099. It's a really rudimentary kind of a level of talking about electrical circuits and phenomena. So there's no prerequisite for this talk. All you need to have is your everyday experiences and common sense that we all have. So let me tell you what makes all of these wonderful devices run. It is electric current. What is electric current, you say? Well, just like a current of water, it is a flow of some material. Instead of water flowing down a pipe, it is electrons flowing down wires. Can you believe that? It is actually some bits of matter, tiny, tiny as they may be, but there are bits of matter, these electrons, that actually flow down the wire whenever you do something. Whenever you turn on the lights, it's electrons that are going through the wires. So, what makes these electrons flow down the wire? Normally, in metals, electrons are just kind of sitting there. They're doing not much. They need to be stimulated to actually move. And what stimulates the electrons to move is a source of power. Let me tell you what that means. Let's go back to our analogy of water. You're all familiar with water towers. They're huge containers of water built way on top, right? They're built that way so that the water will flow into your homes with some pressure. You can actually use it. You turn on the faucet, water comes out. Well, if that water tower was all the way down here on the ground, you would not get any pressure. You would not get any water flow in your home. The fact that that water tower is up is helping push that water flow through the pipes into your home. The difference in the distance is analogous to what we do in electronics, which is potential. Electrons flow with potential. The greater this distance, the greater the potential, the faster they want to flow through the water. Now, you've heard the term volts or voltage. What is that? It's nothing but a way to measure what that potential is, how strong that potential is. The higher the volts, the more forceful those electrons are being pushed down the wire. Another term that you've heard is amperes or amps. And that is nothing more than a way to measure what is the amount of that electron flow. Is it a tiny little bit of a trickle of a current, or is it a large current? The larger the number on the amperes, the more electrons are flowing down the wire. Now, the analogy of water is a useful one, but it doesn't always hold. For example, water flows in a one-way direction. You can have a pipe and this tower, water tower, and the water will just flow all the way down. In electrical terms, the current cannot flow unless if it's a complete circuit. So from the power source, like a battery, that creates that difference in potential, electrons are pushed out along a wire, they go out in a circuit, and they have to come back to the same place. Otherwise, no electron will flow. It can't just be a piece of wire, you put a battery at one end, and current will flow. It has to complete. Okay, so that is the concept of a circuit. You have a power source, and you have a length of wire that goes all the way back. Now, what do we do with this thing? Well, sometimes you may want to have a lot of electrons go through a wire. Sometimes you may not. You may want to have just a little bit. So what you do is that you cut this wire, the circuit, right in the middle, physically cut it, and you put a component in there that the electrons have to pass through. It is called a resistor. The resistor just basically says, I am going to allow only this much to go through me. I am going to resist the electron flow. You have different size resistors that resist differently. Big resistors let only a tiny amount of electrons go through. Small resistors let a whole bunch go through. Another thing which you've heard about, I'm sure, was invented about 70 years ago, and it's called a transistor. Transistor is similar to the same concept of a resistor, where you break this circuit, this wire, and you insert a transistor in the middle, except the transistor is really neat because I can control at any given point in time how much current do I want to let flow through it. It's like a valve. I can turn it on and let a lot of current go through, or I can turn it off and let very little go through. A lot of these electronic equipment and electrical equipment are built based on these simple principles. When you turn on your hairdryer, you know what you're doing? You're turning on that switch, much like a transistor, and you're letting electrons flow. That creates the heat and that blows the air. Now, in a computer chip, there are thousands, millions of these little transistors in these little circuits. By combining these little circuits and interconnecting them in very creative ways, we can make bigger functionality out of all of that small building blocks. Like when you're typing on a keyboard and the letters across the screen appear, well, it's a combination of thousands of those little transistors and circuits that are actually at work. I've told you about some very basic concepts in electrical engineering. Yes, a lot of other things that we use build upon these, and a lot more complex kind of variations come in. But believe it or not, at the heart of the matter, every piece of appliance or electronics that you ever encounter, it is based on this very simple idea. You have a power source, you have a continuous circuit, and you have transistors that allow you to turn the flow of current on or off and vary the amount and the timing. And based on the combinations of these things, you can make wonderful devices that we use every day. And I'm just